All right, review for the Unit 7 test. State the most specific name. Now, this is very important. I won't talk about it, but there are a lot of names for many of these shapes. Like number 1, could be quadrilateral, but it's not the most specific name. So what do we have here? We have those two sides parallel, those two sides parallel. We don't know anything about the measurements or the angles, so all we know is it's a parallelogram. That's the most specific name we can give it. Number 2 is not a square. How do we know that? Because these two sides are equal, and those two sides are equal, but not all 4 sides. So it's not a rhombus, and it's not a square. But since it has 4 90-degree angles, that does make it a rectangle. And number 3, we could say it's a rhombus, and that would be correct. But the most specific name, given that it also has 90-degree angles, is a square. Again, not that it's incorrect to call it a rhombus, or a parallelogram, or a quadrilateral. It's all these things. But down here, looking at your flow chart, we want to go as low as possible to the most specific shape. Okay, now notice, in this, it's telling us these are parallelograms. So all the rules apply. So for number 4, remember, this board hates me. That's what you should remember. Remember that opposite angles are equal. Therefore, this is also 55 degrees. We also know that consecutive angles are supplementary. So therefore, if we do 180 minus 55, we get 125. So this angle is 125 degrees, and opposite angles are equal, so that's 125 also. Number 5. Okay, biggest mistake here is to say they're equal to each other. Look at them. What kind of angle is this? It's a cube. Cute little angle, which is just like this one. So we know this is 70. Now, there's 2 ways to do this problem. If we know this is 70, then we know this obtuse angle is 180 minus 70, which means it's 110. So we know this angle is 110 and this angle is 110. So we actually have 2 things we could do here. We could say that 10x plus 10 equals 110. And then 10x equals 100, x equals 10. That's a shortcut. Now when it says what property did you use, that's a kind of a combination of properties. We know that consecutive angles are supplementary, and we figured out it was 110 and solved it. So we'll write that down. Consecutive angles are supplementary. Just abbreviated. Now, that's the shortcut way. The long way is, as we've been doing so far, is just to say 10x plus 10, the obtuse angle, plus the acute angle, add up to 180. Well, if we combine like terms, we get 10x plus 80 equals 180. And if we subtract 80, what do we get? 10x equals 100. Look familiar? Should. It's right there. Number 6. What property are you going to use here? Opposite angles are congruent. So these two are equal to each other. So I'm just going to say negative 1 plus 10x equals 49. I'm going to add 1 to both sides to give me 50. Divide by 10, and x is 5. Now number 7, be careful in this one. Notice it says km. That's this entire line right here is 38. it says ym, which is just this piece, is 3x plus 4. Now remember, the diagonals bisect each other, which means this is also 3x plus 4. Together they add up to 38. So there's two ways to write this problem. You can write 3x plus 4 plus 3x plus 4 equals 38. Or you can just say 2 of these equal 38. Either way, you're going to get 2 times 3x, or 3x plus 3x is 6x. And when you add 4 plus 4, or do 2 times 4, you're going to get 8. So it does not matter which way you do it. It's just how your brain sees it. We're going to subtract 8. 6x equals 30. And last but not least, we divide by 6. And again, we're going to get the answer of 5. Moving on. Hit pause if you need to. Go back and watch it if you need to. Number 8, what is this shape? Well, it's got 4 90-degree angles. It's a rectangle. And we have no markings about side length. Even though we can see it's not a square, none of the side lengths are marked, so we just say rectangle. And why? 4 90-degree angles. That's all you have to say. Now I want you to list all the angles. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Well, let's go over here and look at it first. So we have parallel lines as a parallelogram. So opposite, okay, if we go on the opposite side of the transversal, which is the diagonals, okay, alternate interior angles match. So that makes this 34. All right? If it makes 90, that makes angle 3 56. And that makes this 56. Now what we have here is a lot of isosceles triangles, which means the base angles are the same. So this is 56, this is 34, this is 56, and this is 34. There are a lot of different ways to justify that. Okay? And then on the inside, we have to do some math. So 34 plus 34 is 68. And if we do 180 minus 68, we'll find out the obtuse angles in the middle. So angle 10 is 112. Right here. And so is S. Right there. And then if we do 180 minus 112, we get 68. Another way we could do that is if we added up these two and subtracted, we'd get 112 also, and then get 68 here and here. So let's fill those out. We have 34 degrees, 56 degrees, 68 degrees. Number 5 is 56 degrees. Number 6 is 34 degrees. 7 is 56 degrees. 8 is 56 degrees. 9 is 34 degrees. 10 is 112 degrees. And 11 is 68 degrees. Now if you need to hit pause to catch up, go ahead and do so. Now number 9. What shape is this? It's a rhombus. How do we know that? 4 congruent sides. So remember in a rhombus, what's special about a rhombus is the diagonals bisect the angles. So if this is 53, so is this. And therefore, opposite angles are equal. These are both 53. Now that makes 106 degrees for these two angles here. So if we do 180 minus 106, we get 74 degrees here and 74 degrees here. And if those are bisected, that makes 37. All right? And these are all special because these are all 90-degree angles. The diagonals in a rhombus bisect at perpendicular angles. So, I'm going to list these out now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1 through 4, I'm just going to save time. These are all 90 degrees. 5, 6, and 7 are all 53 degrees. Angle 8 is 37, and these 3 are all 37. Again, hit pause if you need to. Number 10, what shape is this? Well, we have opposite parallel lines. These two are not parallel, but they are equal. That makes this an isosceles trapezoid. Okay? Why? Because you have one set of parallel lines, one set not parallel, but congruent. Now we have to do some work. Remember, the base angles are equal. Notice how these are both acute angles. So they're equal to each other. So 22x minus 6 equals 60. Add 6 to both sides. We get 22x equals 66. So therefore x is 3 when we divide. Now, if we plug 3 in here, we don't really have to, but we can do it to check. We get 66 minus 6, which is 60. And that makes sense. A and D have to be equal because they're base angles. Now, how do we find B and C? Well, they're congruent to each other. And remember, B and A are supplementary. So 180 minus 60 gives us 120 for B and C. Number 11. This is a trapezoid. Now, it's just a regular old trapezoid because we have one pair of parallel lines and these two are clearly not parallel. So why? One set of parallel lines and one set not parallel. Now, what is, name the segment that's the median? That's CD. Find the length of the median? Well, we take these two numbers and we average them. 16.4 plus 9 is 25.4. And then we divide by 2 and we get 12.7. Last one on this page. Whoops. Nope. Come on. Sorry about that. Last one on this page, number 12. This, like number 10, is basically upside down. It is an isosceles trapezoid. Why is it that? One set of parallel lines, one set not parallel, but congruent. Okay? So, what do we know about consecutive angles? They're not equal to each other. Look, this one is clearly obtuse, and this one's acute. They can't be equal. Don't do it. Most common mistake. 12x plus 17 equals 55. No, no, no. 55 plus 17 plus 12x equals 180. Combine like terms. 12x plus 72 equals 180. Now we're going to subtract 72 from both sides and get 12x equals 108, which luckily is divisible by 9. Sorry, my bad. 12, there's the answer, 9 times. Now, T and Q are both 55 because they're base angles. R and S, well, we have two choices. We can do 180 minus 55 or plug 9 in right here. You're going to get the same answer either way, 125. All right, let's graph. Now please pay attention to this, be careful. When you're graphing, -7 means move left. Then go up. This means left and up. This means right and down. And this means left and down. So A, -7 to the left and 6 up. Right there. B, -2, 8. Left 2, up 8. C, right 2, down 2. And D, left 3, down 4. You've got to be careful about doing that. Now, when you're counting, I think some of you are doing the squiggle thing and you're maybe getting lost. So please, if you can be neat about it or make it really light, otherwise you just tap your pencil as you count. So A to B, I'm just going to go from A and go up 1, up 2. Okay? So that's 2. That's positive. And then from there, I'm going to go right 1, 2, 3, 4, 5. Opposite side, CD, I'm going to try it again. 1, 2, 1, 2, 3, 4, 5. Good. 2 over 5. Now notice, if it says prove it's a rectangle, not what is it, or is it something, if it says prove it's a rectangle, then you know you should get 2 opposite sides parallel. So check your counting and be careful. Now BC, I have 2 ways of doing this. I can go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then go right 1, 2, 3, 4. So I can go down 10 and right 4. Or I can also go up. I could have gone from C to D and gone 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is positive, and left 4. It doesn't matter. I'll do that from D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a positive 10. But then left 1, 2, 3, 4. It does not matter here whether I have a negative top bottom. It's a negative fraction. It's a negative slope. Now, when I compare these two, this needs to be reduced. So that's -5 over 2 and -5 over 2. Now, be careful. If we're doing the distance formula, we have to use the bigger non-reduced numbers. Because think about it. Is a distance of 10 the same as a distance of 5? No, it's going to give us different numbers. So we always have to use the actual full-on slope, not the reduced one, on the distance part. We'll get to that in the next problem. So, on this one, are they perpendicular? Yes and yes. Why is that? Opposite and reciprocal slopes. Same thing for BC and CD. They have opposite and reciprocal. It's important. It has to be both. Okay? So that makes this a rectangle because of the 4 90-degree angles. Again, hit pause if you need to. let's be careful about plotting this. -7, -2 means left 7 and down 2. That's my A. B, 0, 4. So don't go left, don't go right, just go up 4 spots. 9, 2 means right 9, up 2. Positive, positive. That's C. And then D is a right 2 and down 4. Prove it's a rhombus. If it's a rhombus, it's a parallelogram. And all 4 sides are equal, which means all my slopes, it should work out that the distance, I'm sorry, not the slopes, the distance are going to be the same. So from A to B, let's count. 1, 2, 3, 4, 5, 6. Up 6. Right, 1, 2, 3, 4, 5, 6, 7. While we're here, we'll do DC. It should be the same. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. It is. So AB is 6 over 7, and CD is 6 over 7. Now let's do AD and BC. From A to D, I'm going down 1, down 2. So down 2. And then right, 1, 2, 3, 4, 5, 6, 7, 8, 9. And from B to C, I'm going to go down 1, down 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now remember, I could have also gone up 2 and left 9. It would still be a negative slope. Do I have opposite parallel sides? Yes, I do. These two have the same slope. Those two have the same slope. So when I do my distance, I don't have to do it 4 times. A, B, and CD are going to be the same. So I can just do it once. 6 squared plus 7 squared. So that's 36 plus 49. And that's the square root of 85. And then this one, I just have to do it once also. And I don't have to put -2 in. I can just put +2 because it's going to be a positive number anyway. If you put -2, make sure you put it in parentheses, like so. Either way, that's going to give me a +4 plus 81, which, oh, look at that. Same measurement, same distance. So this shape is a rhombus. That's a 3, not an S. Because of not, oh yeah, 4 congruent sides. Why is it not a square? No opposite reciprocal slopes. So therefore, nope. I was going to write the word no, and I wrote a 4. No 90-degree angles. Last one. Okay, let's plot this one carefully. -1, 0 is right here. That's R. U is at 2, 2, so right 2, up 2. U. 8, -7 means right 8, down 7. L. And E is at 5, -9. Certainly it looks like a rectangle, but can't assume anything. So we have to do our slopes and distances. So let's count from R to U. Up 1, 2. Right 1, 2, 3. So that's 2 over 3. Then let's do E to L. Up 1, 2, right 1, 2, 3. That's also going to be 2/3. And then UL, I'm going to go start at L this time just to be kooky. I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. So up 9. Then I'm going left 1, 2, 3, 4, 5, 6. Left 6. Now from R to E, I'm going to go down. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's down 9. And right 1, 2, 3, 4, 5, 6. Notice it doesn't matter. They're still both negative fractions. But to compare opposite reciprocal, I need to reduce 9 over 6 to 3 over 2. So, I don't have to do, well, I do have to do this 4 times, even though it's going to be redundant. I'm not going to actually do it 4 times. So, RU is going to be square root of 2 squared plus 3 squared. And that gives me 4 plus 9. I don't know why I just drew a horizontal line there, which is the square root of 13. So over here for LE, I'm just going to write 2 squared plus 3 squared. Skip the middle step because I've already done the math. Now, here, you've got to be careful. I must do 9 squared and the 6 squared. Because that's going to give me 81 and 36. And that will give me 117. Notice, if I would have done 3 and 2, I would have gotten this. Now think about it. If I would have used the reduced numbers, I would have gotten root 13 on all 4, saying that this is a rhombus or a square. Does that look like a rhombus or a square? No. So you've got to think about whether or not your answer makes sense or not. So over here, I'm going to use the big numbers again, skip the middle, and just say 117. So this is a rectangle because it has 4 90-degree angles. And that's it.